All right, so we are on our second part of that same section, 55B, distinguishable permutations. And the formula for distinguishable permutations is the number of items we have, factorial, divided by the number of things that are the same, factorial, and then this is dot, 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 because it depends on how many things we have that are the same. And I want to show you with the letters in the word mom. Okay, how many distinguishable ways could we write the word mom? Because there's no way to tell the difference between the two M's. Okay, we couldn't distinguish between them unless they were some sort of different color. Okay, so basically if we were to do this with a regular permutation, we would have, maybe we'd call this an M1 and an M2. Okay, so M1, we know that for three things, we should be able to do what? 3, 2, 1 different ways, or 6 different ways to write the letters M-O-M that would be distinguishable if we had an M1 and an M2 that we could see, okay? So basically I could write them what? I could start with M1, and then I could either have an O, M2, or I could start with M1 and I could have an M2, 0, right? I could write them that way. I could start with O, and I could write an M1 and an M2. I could start with an O, and I could write an M2 and an M1. Or I could start with the what? The M2, and I could have an M1 and an O. I could start with the M2, and I could have an O and an M1. Those are all the different ways that I could write the letters of mom. But how many of them would be, so there's my 6 ways, right? But how many would be distinguishable if we didn't have the M1 and the M2 on there? That we would say, how many really, truly different ways could we do it? Okay, so basically we have a mom here, and we have a mom down here. Those are the same. Okay, we have an MMO and an MMO. Those are the same, right? We have an OMM and an OMM. Those are the same. So we've got really only 3 different ways that we can distinguish the letters in mom. Yes?
Can I go blow my nose real quick?
Yes. Okay, so now when we look at this example in this formula, we've got 3 letters. So it'd be 3 squared on the top, right? But then we have 2 letters that are the same. Okay, so down on the bottom, because there's 2 letters that are the same, we would write 2 factorial. Okay, so when we went ahead and did that, now we don't have any others. We don't have a B and a C because we don't have any other repeated letters. But once we have that, we say, well, 3 factorial is 3 times 2 times 1, or 6, and 2 factorial is 2. So we have 3 distinguishable ways to write the letters in mom. Okay, so now let's look at this one over here. Okay, we have JoJo has 10 marbles. And 10 marbles would be a lot more difficult to do this little analysis with, wouldn't it? Okay, it'd take you a lot more time. I just showed you something easy because it was small. All right, so we're going to follow the formula for the rest of these. I just wanted to show you why the formula works. JoJo has 10 marbles. So up on top, we'll have 10 factorial, right? And then on the bottom, how many does he have that are repeated, Peter? Peter, you're now behind the computer. How many does he have that are repeated, Selena? Okay, you're up here too. How many does he have that are repeated, Susie?
I don't understand what you mean by repeated.
Okay, I'm saying we've got what? 3 reds.
Yeah, but like each one's repeated.
3 blues. Okay, so we've got reds are repeated 3 times. We've got blues are repeated. That's what I'm wanting you to say. Blues are repeated 3 times. Greens are repeated 4 times. Okay, so here we go. 3 reds are repeated. So I'm going to use 3 factorial on the bottom. 3 blues are repeated. So again, I'm going to have another 3 factorial on the bottom. 4 greens are repeated. So I'm going to have a 4 factorial on the bottom. So when we go to checking that out, we've got what? 10 factorial over 3, 2, 1, 3, 2, 1, 4, 3, 2, 1. Okay, so 10 factorial would be what? 10 times 9 times 8 times 7 times 6 times 5 times 4, 3, 2, 1. So won't this 4, 3, 2, 1 cancel this 4, 3, 2, 1?
Yeah.
Okay, and then, well, I got a 3 and a 2, which would cancel a 6. So we can get rid of the 6. And then I've got another 3 and 2, which could cancel, well, that 3 could cancel the 9 with the 3. And that 2 could cancel the 8 with a 4. Okay, so I've canceled out the bottom, and what do I have left is that how many different ways I can do this. 70 times 12. What is 12 times 70? Is that 840?
Yes.
840 different
You
ways.
have to multiply by
Um,
You got a thing. Just tag.
did I lose the 5? Oh, the 5. You're right, I lost the 5. Times 840 times 5.
4,200.
4,200. Okay, so that is correct. I lost my 5 there. So it's 4,200 times the 5. Okay, but does everybody see how it works? It's not difficult once you know the formula. Okay, so now how many different permutations can we come up with the word nonsense? So first we're going to count 1, 2, 3, 4, 5, 6, 7, 8 letters. So 8 factorial will go on the top. Peter, what will go on the bottom? David, what will go on the bottom?
3 is it factorial?
Okay, 3 factorial, which one are you seeing?
The N.
The n. He sees 1, 2, 3 n's. So we'll say 3 factorial on the bottom to take care of the n's. Does anybody see anything else? Allie?
2 S's.
2 s's. So we have an s and an s. So we're going to have 2 factorial on the bottom. Is there anything else?
2 E's.
2 e's. So we have an e and an e. So we're going to have 2 factorial again. Anything else? Okay. So now, would somebody get that for me?
I got it.
Okay, so we've got 8, 7, 6, 5, 4, 3, 2, 1 on the top. And the bottom we have 3, 2, 1, 2, 1, 2, 1. So when we go to cancel, we've got 2, 2, 2 is 8, isn't it? And then we've got a 3 here. And we're going to multiply together 42 times 20 times a 2, so 42 times a 40. 42 times a 40. And when we do that, what do we get? We should get 1680.
Yes.
And we do. Okay? So, does everybody see how that works? Easy stuff if you know the formula, if you know the little trick. Okay? Any questions on any of that?